So I'm going to talk to you about here. I go through this presentation on the CNC lathe. It's based loosely on the Tooling U modules, the 4 modules that we were working on this week, and we're doing this in preparation for the new CNC machines that will be showing up shortly. So there's a picture of the lathe. That's actually the model that we're getting. There's 2 different types. The first type would be the horizontal lathe. It's very, very similar to the ones that we had. It's very common. The spindle is parallel to the floor. Although not as common, the spindle perpendicular to the floor would be on a vertical lathe. So basically they took the machine and they turned it sideways. Still another type of lathe would be something called a turning center. This is similar to the lathe, but it has a live tooling attachment. That's this guy right here, where what you can do is stop the spindle and then put a milling machine cutter or drill bit into this, and it will machine complex cuts on the outside of the part, or drill holes into it or something like that. Lathe specifications. Lathes are typically specified by their maximum cutting diameter. That's the biggest piece they can fit on them. The maximum length in between centers, so the longest piece that you could accurately cut or machine. The swing, which is the distance between the center of the spindle and the cross slide, how big of a piece you can actually fit in there. Number of tool stations, spindle RPM, and the spindle motor horsepower. So if you're doing very, very large pieces, you need a machine with a little bit more horsepower. Versus if you're doing a lot of small pieces, you maybe want something that doesn't need as much horsepower but has a faster RPM. Basic parts. You have a headstock. As the operator stands at the machine, it's going to be on the left side. The headstock has a spindle. The spindle is the portion that rotates and turns. Your bed is the part of the lathe that holds basically the rest of the attachments. The center and the tailstock ride on the bed. The bed has something on it called the ways, and the ways are what the carriage and the tailstock ride on top of. They're machined, they're precision machined, and to allow the carriage and the tailstock to move very nicely and easily and accurately while you're machining a part. Continuing, on top of the carriage, we have the cross slide. This moves in and out. For right now, I'm going to just talk about in and out and left and right, or forward and back and left and right. Your turret is what on a CNC machine would have the different cutting tools in it. So you would have the opportunity to program the machine to do a facing cut at first, and then do some sort of profiling cut, and then maybe come back and put a chamfer on it, or drill a hole without the operator changing the tool. So that part of this machine that holds all of your cutting tools is called the turret. The picture on the right here, the movement of the lathe, the carriage moves left to right, or in this case it's going to be in the Z axis, and the cross slide moves forward and back in the X axis. Okay. Speaking of axes and lathe coordinates, we're working with something called a Cartesian coordinate system. If you remember maybe from like math class that you took, it's exactly the same as it would be for a milling machine. Here they are. Here's your right hand rule to help you kind of remember them. But the difference with a lathe is there's not really a y-axis. For most of what we're going to be doing, there's not really a y-axis. There's X and there's Z. There's also A, B, and C when you deal with live tooling centers on there, but we're not going to get into that right now. Machine 0 and Part 0. Seeing as how this is a CNC machine, it will come with a factory setting called Machine 0. And basically this location is a place where the tool has moved way away from the part you're working on, and it's sort of like the home position. Right, so the machine, when you turn it on, it will go to this Machine 0 position. The program 0 is the spot right here where you're going to use as your origin to create your part from. It will be specified on the drawing, most likely with a datum. This will be a unique location for each individual part you're machining, and the operator has to set this up. They have to program this point, program 0, into the machine. This offset between program 0 and machine 0 is called a work shift offset. That's a little extra there. Speeds and feeds. We talked a little about this with a milling machine, but speeds and feeds on a lathe are almost identical. The formulas are the same. The only difference is the RPM on the milling machine is how fast the cutter rotates. On a lathe, it's how fast the workpiece rotates. So you'll have to set the machine up or program into the machine how fast you want the machine to rotate based on your speed and feed calculation. Feed is the speed at which the cutter moves into the material. So versus the CNC mill, where the table and the clamp with the piece of aluminum on it moves, now we're talking about how fast we control the tool moving. There's a bunch of different lathe operations here. I'm not going to go through every single one of them. I'm going to skip over threading and contouring and forming. But the rest of them you'll see in the next couple of slides here. So facing reduces the length of the workpiece. You're cutting this to length. This is done first so that you have a smooth, clean surface. This would be a top-down view of your lathe in this picture. This is done first so that you have a clean, smooth, non-bandsawed cut to establish your program 0. So what happens here is the machine turns on and the operator moves the tool perpendicular to the axis or in the x-axis and cut a little bit of material off. Shoulder turning, or just regular turning, your tool is going to move in the x-axis a little bit, and then it's going to move, so it'll start here and come in the x-axis, and then it will move in the z-axis, removing material. Okay? If you have a spot on your workpiece that has two different diameters, that is called a shoulder. So for like the meat tenderizer hammers, there is a shoulder on there that we'll be working on turning on those. Taper turning. This gives a piece a conical shape. So anytime you see anything with a question on a Macwick or a question on a tooling U or a NIMS, it says it makes a cone. It's a taper. A taper is made by moving in both directions at once, the X and the Z. So this tool is moving both in the X direction as this gets smaller or larger, and it's also moving in the Z direction because it's moving left to right here. Don't worry about the angles and stuff. We'll calculate that later. Chamfering is similar to tapering, except for you're not cutting a whole lot of material, you're just basically taking a little bit off the corner of the workpiece to make sure that the edges aren't sharp. Chamfering edges on bolts and the end of a shaft to make sure that they fit into the hole is something that's very commonly done. And for this example, they're just using a tool that has the chamfer they want ground on it already. And they just basically brought the tool up and kissed a little bit of material off the workpiece. So knurling. Knurling we talked about briefly in class, before we got dismissed here into this remote system. It basically gives you a nice diamond pattern for improved grip on a workpiece. You'll see here that we have a tailstock introduced into this, basically because there's a whole lot of forces going on in the X direction, because you really have to press with a fair amount of force with this knurling tool and then feed it. And 2 or 3 cuts will give you your full impression. It's done at a very low speed. And we'll get more into this as we get back into the shop. But just so you know that this is another type of lathe operation. Okay, grooving is very similar to facing, except for you're not doing it on the end, and it's done typically at the end of threads. So when you get to the end of a series of threads, you want to cut just a little bit more material out so that your threads don't bind and you don't have a rounded out shoulder there. We did this on some of our meat tenderizer hammers. We did this on by hand. So we used a small grooving tool, which was very thin, and we cut just a little bit of material out, making the part have a square shoulder. And drilling. So you can drill a hole on something using a lathe. Typically we think of a drill as the drill bit spinning, like a hand drill or a drill press or a milling machine or any basic other type of drilling machine. The drill bit is what spins. On a lathe, it's the exact opposite. The drill bit is held tightly in the tailstock with either drill holder or a chuck, and the workpiece rotates. So you may have to adjust your RPM rate between doing an outside turning operation, such as grooving, and drilling. This is most likely going to be done a little bit faster because you're dealing with a smaller diameter drill bit here. So what happens is the machine turns on and the drill bit moves in the Z direction towards the headstock, and then you pull it back out and drills your hole. And there are all the references I used to find pictures and document this presentation. So hopefully we'll put some questions out, or I will put some questions out for you based on this. Hopefully you all went through the Tooling U modules that I posted on Classroom. I did as well. A lot of information in there. I sort of condensed it down with this presentation. And let me know if you have any questions.